Our next test for convergence or divergence in our infinite series unit is the telescoping series test. It's called telescoping because it's going to be a series in which terms end up canceling out and it collapses down to a value of just one or two terms. So if you look at this initial one up here, we have a series, it's 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4, and then it goes on in that same pattern. Notice that we begin with the value 1, and then we have minus 1/2, and then we have a plus 1/2. And so we have these values that end up canceling each other out because they have opposite signs. And so in this first example up here of what a telescoping series looks like, we would end up saying that this converges to the value 1 because every other term ends up canceling out as you expand the series. So that's what the telescoping series test looks for. So example 10, part A. We're going to look here. We have this series as n goes from 1 to infinity of 1 over 2n plus 1 minus 1 over 2n plus 3. When we write out some of the terms to see, what this series looks like, we suspect it might be a telescoping series, then we would go ahead and write out some terms. So when n is 1, then this first term we would end up with 1 over 3 minus 1 over 5. And then when n is 2, we end up with 1 over 5 minus 1 over 7. And when n is 3, we end up with 1 over 7 minus 1 over 9, and it appears like this pattern is going to continue. That's really nice because these subsequent terms end up canceling out, so we have 1/5 cancels with 1/5, 1/7 cancels with 1/7, 1/9 will cancel with what the next one would be, which would have been 1/9 as well. And so the only term that's going to remain is this 1/3. So we would say that if S sub n is the series that we looked at, then we would say that S sub n converges to 1/3 by the telescoping series test. Okay. It's that simple. So you just want to list out some terms, look for the pattern, and then you can get what the value converges to if it converges. Okay, so let's look at example 10, part B. In this example, we have our series is written as 1 over n times n plus 1. What I'd like to do to see if it's a telescoping series test is to see about writing it in a format similar to what we saw in example A, because then we have this nice sum and it's easy to do the terms and to see how they may be alternating signs and eventually canceling each other out. So let's see if we can write this in that form. And how do we do that? Well, if you remember from not too long ago, we can do this by rewriting it as our partial fractions, the sum of the two fractions. So we're going to have, we need this to be the sum, as n goes from 1 to infinity, of something over n plus something over n plus 1. And, oops, sorry, should have made that be an A, not a 1. Okay, so then we have A times n plus 1 plus B times n equals 1, because we need the sum when we get the common denominator to equal the 1 in the original. And so when n is -1, then we have this first term would go to 0, and we'd end up with b times negative 1 equals 1, so b equals negative 1. And when n equals 0, which is what would make the second term 0, then we have a times 1 equals 1 and a equals 1. So our fraction will break down to the sum, as n goes from 1 to infinity, of a over n, which a we said was 1, so 1 over n, and then b over n plus 1, and b is negative 1, so I'm going to write it as 1 over n plus 1. So there we have that nice minus sign, which hopefully is going to lead to that, that cancellation of terms in the middle, and we would hopefully then end up with a converging, with the series converging to a finite number. Okay, so let's write out a few terms here. So when n is 1, we would have 1 minus 1/2 plus, when n is 2, we'd have 1/2 minus 1/3 plus 1/3 minus 1/4, and so on. So this is another one where we are canceling out these subsequent terms, and that works out kind of nicely for us. Okay, now don't assume that it's always going to end up being the first term is what it's going to converge to. There are going to be times when you have series that there will be other terms that don't cancel out as well. So we'll look at some of those. Okay, so we would say, or we have to draw our conclusion. We can't just leave it here. And we would say that if S sub n equaled that series, that S sub n converges to 1 by the telescoping series test. Okay. All right. So now we're going to look at example 10C, which is going to work in a similar manner. And we're going to need to rewrite this one as well so that it also looks like the sum of some 2 or more terms. Okay, so our first step, we're going to want to factor this denominator, and it would factor to n plus 3 and n plus 1. So those are going to be the denominators of our sum that we're going to break this down into. So I'm just, to give myself some room, I'm going to write it way over here. So the series is n goes from 1 to infinity of 1 over n squared plus 4n plus 3. We're going to write it as, it's going to equal a n plus 3 plus b over n plus 1. Okay, so that's this. That's what we're doing here. Okay, so we do the same thing again. So a times n plus 1 plus b times n plus 3 is going to equal 1 again. And so when n equals negative 1, the first term goes to 0, and so we'll have 2b equals 1 and b equals 1/2. And when n equals negative 3, then we'd end up with negative 2a equals 1, so that a equals negative 1/2. So this works out to be the sum from 1 to infinity of negative 1/2 over n plus 3 plus 1/2 over n plus 1, and that's written kind of yucky. We can actually factor out that 1/2 and pull it outside, just multiply it at the end. And I'm also going to, just to have that negative in there, you don't have to, but I'm going to put the terms into a different order. So here we go. We've got 1/2 outside, and then we're going to do the sum is n goes from 1 to infinity, and we're just going to write it as 1 over n plus 1 minus 1 over n plus 3, just to get that minus in between instead of it sitting out there at the front. It doesn't matter. You get the same result. Okay, so let's start to evaluate it. We are starting at n equals 1. So when n equals 1, then we're going to have 1/2 times, and that would be 1/2 minus 1/4, plus, now when n is 2, we'd end up with 1/3 minus 1/5. And so this is where we go, whoa, wait a minute, things aren't canceling out. You want to keep going. Don't stop after just 2 terms. That's not long enough to see what the pattern is. Okay, I'm going to bring it down here because I started too far over and I don't have enough room. So when n is 3, then we're going to have 1/4 minus 1/6, plus when n is 4, we'll have 1/5 minus 1/7. And do you see what's starting to happen now? So we've got a positive and negative 1/4, so they'll cancel out. Okay, we've got a negative 1/5 and a positive 1/5, so they'll cancel out. So guess what's going to happen then in the next term? If we keep going and we write the next one, then we're going to have, we are up to 1/6 minus 1/8 plus, and so the 6's are going to cancel now, the 1/6. The next term would end up starting with 1/7, and it would cancel, 1/8, and it would cancel. So what we have here is 2 terms that did not cancel out of our sum, and we cannot forget about the 1/2 that we have multiplied out front. So we end up with 1/2 times the sum of 1/2 plus 1/3. Here's the 1/2 that's on the outside, that's the 1/2, and there's the 1/3. Sorry for the mess. So that's going to be 1/2 times, and 1/2 plus 1/3 ends up being 5/6. And so we would end up with 5/12. So we would say, again, that if S of n is that sum, then S of n converges to 5/12 by the telescoping series test.